GenAI and MLOps Part 6. This episode has 25 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Scenario or GenAI RAG? Scenario. A GenAI chat feature gives outdated or irrelevant answers from your knowledge base. How would you debug and redesign the RAG pipeline? Here's a strong way to approach it. Break the pipeline into ingestion, chunking, embedding, indexing, retrieval, re-ranking, prompt construction, and generation. Check whether source documents are fresh, chunks are too large or small, embeddings match the query domain, metadata filters are correct, and top K results are relevant. Add retrieval evaluation sets, citations, recency metadata, document re-indexing, hybrid search if needed, re-ranking, and feedback loops for bad answers. Nice. Let's continue. Question 2. Scenario or GenAI safety. Scenario. A user tries prompt injection to make your AI assistant reveal internal documents. How would you prevent and monitor this? Here's a strong way to approach it. Treat all user input and retrieved text as untrusted. Enforce authorization before retrieval. Isolate tenants. Keep system instructions separate. Filter retrieved documents by permission. And never put secrets or hidden policies in retrievable content. Add prompt injection classifiers or rules. Tool allow lists, output checks, refusal behavior, and audit logs. Monitor blocked attempts, unusual retrieval patterns, sensitive document access, and user reports. Great. Moving on. Question 3. Scenario or GenAI cost. Scenario. Your LLM API cost increases 5 times after adding a new AI feature. How would you investigate and optimize cost without hurting quality? Here's a strong way to approach it. Break cost down by feature, tenant, model, prompt version, token input or output, retrieval size, retries, and cache hit rate. Find whether prompt length, context size, traffic, model choice, or repeated queries caused the spike. Optimize with shorter prompts, smaller models for simple tasks, response length limits, semantic caching, better retrieval top K, batching where possible, rate limits, and quality evaluations before changing models. Alright, next question. Question 4. Scenario or resilience. Scenario. A third-party payment or email API is unreliable. How would you design retries, fallbacks, idempotency, and user experience? Here's a strong way to approach it. Set strict timeouts and retry transient failures with exponential backoff and jitter. Use idempotency keys so repeated requests do not double charge or duplicate messages. Put operations on a durable queue when user-facing latency should not wait for the provider. Add provider-specific circuit breakers, dead letter queues, status tracking, reconciliation jobs, and user messages that are honest, pending, retrying, failed, or completed. Let's keep going. Question 5. Scenario or data pipeline. Scenario. A background worker pipeline falls behind and queue depth keeps growing. How would you debug and redesign it? Here's a strong way to approach it. Check arrival rate versus processing rate, worker errors, retry storms, poison messages, dependency latency, CPU or memory, DB locks, and queue visibility timeout. Short term, scale workers, pause noisy producers, and isolate poison messages. Long term, partition queues by priority, add back pressure or rate limits, improve task idempotency, batch safe operations, tune concurrency, autoscale on queue age, and add dead letter handling. On to the next one. Question 6. Scenario or migration. Scenario. You need to migrate a monolithic Django app to services without stopping product delivery. What migration plan would you propose? Here's a strong way to approach it. Start with a modular monolith cleanup, clear boundaries, domain ownership, tests, and observability. Choose one low-risk bounded context, expose APIs or events, and use the strangler pattern to route that capability to a new service while the monolith still runs. Keep shared database changes careful, prefer backward-compatible contracts, migrate data incrementally, and use feature flags. Avoid splitting everything at once. Measure reliability and team velocity after each extraction. Good. Here's another one. Question 7. Scenario or architecture review. Scenario. You are asked to review a proposed full-stack AI application before launch. What risks, trade-offs, and readiness checks would you cover? Here's a strong way to approach it. Review functional requirements, data flow, auth, tenant isolation, threat model, PI handling, model or provider choice, RAG quality, prompt injection risk, cost controls, latency slows, fallback behavior, observability, evals, CI or CD, rollback, database migrations, capacity, and incident runbooks. Ask what can fail, who is impacted, how it is detected, how it is mitigated, and what evidence proves the system is ready for production. Nice. Let's continue. Question 8. Kubernetes or networking? Explain CNI in Kubernetes. We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Great. Moving on. Question 9. Kubernetes or networking? Which CNI have you worked on? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Alright, next question. Question 10. Kubernetes or service mesh? Do you have experience with a service mesh? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Let's keep going. Question 11. Kubernetes or service mesh? Can you explain what a service mesh is? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. On to the next one. Question 12. Kubernetes or workloads? What is the difference between a deployment and a stateful set? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Good. Here's another one. Question 13. Kubernetes or probes? How do liveness and readiness probes differ? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Nice. Let's continue. Question 14. Kubernetes or containers? What is a sidecar container? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Great. Moving on. Question 15. Kubernetes or ingress? What is an ingress controller? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Alright, next question. Question 16. Kubernetes or autoscaling? How do you handle pod autoscaling? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Let's keep going. Question 17. Kubernetes or secrets? What is a Kubernetes secret? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. On to the next one. Question 18. Linux or Kubernetes? What is BusyBox? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Good. Here's another one. Question 19. Kubernetes or eth? What does eth store? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Nice. Let's continue. Question 20. Kubernetes or eth? Does eth store namespaces and storage configurations? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Great. Moving on. Question 21. Deployment strategies. What is blue-green deployment? Here's a strong way to approach it. Blue-green deployment runs two environments, the current production version and the new version. Traffic is switched to the new environment after validation, and rollback is fast by switching traffic back. Detailed interview explanation. Blue-green deployment belongs to the software delivery life cycle. In interviews, explain how it helps teams move from source code to production safely. The key themes are automation, repeatability, traceability, testing, security validation, deployment control, and rollback. Production example. A production pipeline may start when a pull request is opened. CI runs unit tests, integration tests, static analysis, dependency scanning, and image scanning. After approval, the pipeline builds an immutable artifact, pushes it to an artifact registry, and deploys it using Kubernetes. Helm. Argo CD, Flux, or another deployment system. For production releases, teams add approval gates, canary or blue-green rollout, slow checks, and rollback automation. Best practices to mention. Keep pipeline definitions in Git and review them like application code. Promote the same immutable artifact across environments. Use secret managers and short-lived credentials instead of hard-coded secrets. Add automated checks for tests, security, policy, and deployment health. Measure delivery using DORA metrics, deployment frequency, lead time, change failure rate, and MTTR. Common interview follow-ups. You may be asked how to handle flaky tests, slow pipelines, failed deployments, manual approvals, artifact promotion, branch strategy, GitOps drift, or rollback. A strong answer connects the concept to faster feedback, safer releases, and better auditability. Alright, next question. Question 22. Helm. What is the use of Helm? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Let's keep going. Question 23. Cloud networking. What is the difference between AWS VPC, Azure VNet, and GCP VPC? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. On to the next one. Question 24. Hybrid networking. How do you connect on-premises resources with cloud resources? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Good. Here's another one. Question 25. Cloud networking. What is a VPC? Here's a strong way to approach it. A VPC, virtual private cloud, is an isolated, logically defined private network within a cloud provider where you control IP ranges, subnets, routing, and connectivity for your resources. Nice. Let's continue. That wraps up this episode. Nice work practicing, and see you in the next one.